Hello everyone, today we are going over part 1 of the digestive system, and we'll go ahead and start with our question of the day. Should you pre-chew the food you feed your baby? This is also known as pre-mastication. Yes, it's a thing. Mastication means chewing, pre means before, so you're chewing it before your kid eats it. And we'll talk more about that in a little bit. So for the pre-lecture assignment, gonna see what I want to go over here. I want you guys to know that there are two parts of digestion. There's mechanical digestion and chemical digestion. So mechanical digestion is just what it sounds like. It's just breaking the food into, I'm on the wrong line, sorry. Breaking the food into smaller pieces. So nothing really chemically going down, just think of taking a piece of bread and ripping it into smaller pieces. Whereas chemical digestion is when bonds in food are broken into smaller pieces by enzymes. The layers, let's see, put the following layers of the GI tract in order from, well, before I move on to this, I want to emphasize that, I don't want to say the purpose, but the purpose of digestion is to take those food particles and get them small enough, break them down into their monomers, because that's only when they can get absorbed into the bloodstream. So you're breaking down these big like proteins and these big carbohydrates into their monomers so they can be absorbed into the blood. For this, put the following layers of the GI tract in order from inside to out. So number 1 is going to be the innermost layer. So number 1 is the lumen. And the lumen isn't actually anything except open space, really. So it's not really a structure. It's just the empty space in here. And it's the open area that contains the digested food. And the next layer that you'll come to here is the mucosa. And that secretes protective mucus, just like it sounds, mucosa. And what you'll see next is the submucosa. This contains blood vessels and nerves and carries nutrients absorbed by the mucosa. So the word sub means below, so you can think of mucosa, and then submucosa comes next. And then next will be the muscularis. These are layers of perpendicular muscle responsible for peristalsis. Those are the contractions that kind of squeeze your food through your digestive system. So you can see some of that here. You can see they go in 2 directions, and we'll talk more about that later. But that might be easy to remember. Muscularis, muscle, it's those muscle layers that help squeeze your food through. And then finally is the serosa, and this secretes lubricating fluid so your food can slide right through. Okay, so that's all I want to go over for the pre-lecture. So digestion begins in your mouth. So this is mostly mechanical digestion. So you're going to chew, you're going to break things down with your teeth. So the mechanical involves your tongue, moving stuff around, and your teeth, obviously breaking things into smaller bits. But with the mechanical, remember, nothing chemically is changing, you're just breaking it into smaller pieces. And there is some chemical digestion that occurs in your mouth. So you have the salivary glands, which make saliva, and you have 3 pairs So on each side, you've got the sublingual gland. Remember, sub means below. Lingual means tongue, so that's the one below the tongue. You've got the submandibular gland, just below the mandible. Makes sense. And the parotid, I honestly don't know where that word comes from, but the parotid gland, and then you've got some, those salivary gland ducts, so the saliva can get into your mouth. The enzyme they secrete is called a salivary amylase. And what this does is begins the digestion of starch. So in one of the other chapters, I think it was macromolecules, I talked about this a little bit. If you take a saltine cracker, which is very starchy, and you just let it sit into mush in your mouth, it will, after a couple of minutes, it will start to taste sweet because this enzyme, salivary amylase, is starting to break down that starch into sugars, and you can actually taste this process happening. So if you didn't already, go ahead and stick a saltine cracker in your mouth and let it soak in there until it's nice and gooey. Sit there for a couple minutes and see if you can taste the sweetness. Okay, to help you answer the glorious question of the day, discuss in groups the possible pros and cons of pre-chewing food for your baby. So I just want you to think about this. You can make a list or just think in your head, what would be some good things about this and what would be some bad things about this. And if you want to watch this YouTube video, you can. It's actually, I think it's pretty funny. It's Jimmy, oh, which Jimmy is it? Jimmy Kimmel, I think, on his late night show. And if you're familiar with any of his content, he challenges his watchers to do like pranks on their loved ones and then record it and send it to him so he can show the rest of the world. And there's a video of that somewhere got posted of Alicia Silverstone, I think is how you say her name, chewing up some food and then spitting it into her baby's mouth. It looks like the kid is like around the age of 1, I would guess. And some people lost their minds and some people were like, yeah, but that's a thing, we do that. So if you want to watch that video, it's funny, but as far as the content for the class goes, it's not really necessary, but let's talk about this for a minute. So should you pre-chew the food you feed your baby? So this is something that, again, if you're working in the medical field, that you might encounter. So pre-chewing is still the norm in many non-Western cultures that don't have this baby food available to them. So the act exposes infants to their mother's saliva, giving them an immune system boost. So we'll say that's a pro. Immune system boost. From mom's saliva. I'm sorry, my voice is a little scratchy today. I had to get angry with one of my classes. And that's something that they can't get from that sterile baby food that you buy at the store. But a con is that they can catch infectious diseases from the mom. So anything that mom can be carrying can be obviously passed to that baby through the food that she's essentially spitting into their mouths. Some pros, unofficial pros I would add is it probably saves money. It's easier. In some countries, it's probably the only option, but cons, you can pass diseases on to your kids. So there we go. All right, so after the mouth, your food moves into the esophagus, which is the tube that moves food from your mouth to your stomach. And it does this using a process called peristalsis. And so it's kind of these muscular contractions that are going to squeeze the stuff you just swallowed, we call it a bolus, down your esophagus and into your stomach. There's this structure right here called the lower gastroesophageal sphincter, and it will relax and let food into the stomach. So no digestion or anything is happening here. It's just a simple passageway to get from the mouth to the stomach. So this bullet point moves food to stomach. And it does this using smooth muscle contractions. And they're wave-like. So think of those contractions just coming in waves, squeezing the food down the esophagus to the stomach. And then the lower esophageal sphincter acts as a valve to the stomach. So your esophagus is essentially a ring of muscles. So the question down here at the bottom, are the muscles involved in peristalsis somatic or autonomic? So thinking back of, let's see, what was this? The nervous system. Somatic is what controls muscles, and autonomic is like things that happen involuntarily. So do you ever have to think, esophagus, I need you to squeeze my food down to my stomach? No, it just happens. So it's autonomic, and I think of that as automatic or involuntary. And then sympathetic or parasympathetic. So I don't know if you remember this, but sympathetic is when you're in like fight or flight type situations. So if you're getting chased by a bear, your sympathetic nervous system is gonna be more dominant. And parasympathetic is your rest and digest. So it's got the word digest in there. So I would say that this is parasympathetic. Sorry, my paper won't stay. All right, before we move on to the stomach, a couple of things here is when you have heartburn, and this might come up later, I can't remember where it is in the packet, but heartburn is nothing to do with the heart. It's when food from your stomach comes in the wrong direction out this lower esophageal sphincter, and you've got hydrochloric acid in here. And if your stomach has like protective mucus layer and stuff, but the esophagus doesn't. And so if food gets back up in there, it will burn. And when I was a teen, I know I'd love to tell you about all my health problems. I was diagnosed with GERD, GERD, and I think it stands for gastroesophageal reflux disease. But I had to go in and get uh oh, there's a name for it, but where you swallow the barium, and so they can watch as you swallow food and record it. And I was diagnosed with dysphagia, so difficulty swallowing. And then at that time, they did an endoscope, which is where they take a little flexible camera and stick it down your esophagus. And they went into my stomach to see what was going on there. And they diagnosed me with that reflux disease. And then also, I had scars from ulcers in my stomach. So, side note, I was a very anxious, stressed kid. And once I got my stress and anxiety managed for the most part, these things went away. Not saying that would be the case with everyone, but stress or anxiety can contribute to these disorders. And then that's when they put me on a proton pump inhibitor, omeprazole. It's just over the counter. And that made my stomach acid less acidic. And mine was so bad that if I took a drink of milk and swallowed cold milk, I would feel it go down. And then I would feel the coldness go whoop right back up. It was really weird, but I'm glad I don't really have issues anymore. Okay, anyway, onto the stomach. So we started in the mouth. We have mostly mechanical digestion there. A little bit of chemical digestion with that salivary amylase that starts to break down the starches. And the stomach, again, is like an extension of the esophagus. Here's where it talks about it. The esophageal sphincter, right here, between the esophagus and the stomach, separates the stomach from the esophagus. And when it's open, can cause heartburn. And some things that can contribute to this, aside from stress, are obesity, pregnancy, and let me tell you, I had a rough go with that. Eating too much. So anything that's going to put pressure on your stomach to kind of force food out can contribute to this. So obviously, if you're pregnant and you've got a baby squishing all your organs around, it can cause heartburn. Obesity, if you eat too much, you've got too much food in here, it can seep back out that way. And then also genetic susceptibility. My dad was also diagnosed with the same thing that I had, so that played a part as well. And then we have another sphincter right here. So here's our stomach, here's our esophagus, and here is the start of the small intestine. And this is called the pyloric sphincter. It separates the stomach from intestines. And it allows a small amount of chyme, that's the food that you've eaten mixed with all the acid and juices in your stomach, into the intestine at a time. So you don't want this just rolling through. It needs to be controlled, and it'll just open every once in a while and let a little bit in. So back to the stomach, there's an oblique layer of muscle in the muscularis layer, and it's only located in the stomach. And it has a diagonal muscle orientation. So think of the muscle fibers running like that. The word oblique means angle. So that's why it's called that, the oblique layer, because those muscle fibers are running at an angle. And this allows the stomach to expand and contract to mechanically break up food. So you can just squeeze it and break it up into smaller bits. So that churning you feel in your stomach is your stomach muscles actually squeezing and breaking the food mechanically into smaller pieces. Gastric pits, that sounds delightful. If you look here, this is a obviously magnified image of the lining of your stomach. And you have these little gastric pits here that are part of the mucosa layer. And these pits lead to glands that secrete gastric juice. Called gastric juice. Sorry for the squishy notes here. And what's in that gassy juice are two things. We have hydrochloric acid. That's HCl. And something called pepsin. No, computer, do not restart right now. Thank you. Okay, so the hydrochloric acid is going to kill most of the bacteria that you ingest. So obviously this doesn't always work. If you ingest a large amount of bacteria, you can get food poisoning, but some of the times your stomach the hydrochloric acid will kill any bacteria that you have ingested. And pepsin breaks down proteins. So know that pepsin is found in the stomach, in those gastric juices, and that it breaks down proteins. So in your stomach, there's not really a lot going on. The food is getting mechanically breaking down into smaller pieces. The pepsin starts to chemically digest these proteins down into just smaller proteins. And there is some absorption that happens here, but not a lot. But there will be some water water-soluble vitamins, and alcohol. So I don't know how many of you have drank alcohol before, but if you have, if you do it on an empty stomach, it's going to hit you hard and fast. And I don't know if you've been to parties before or whatever, but someone will be really intoxicated and they'll be like, get that girl some bread. So, not speaking from personal experience or anything, just anyway, if you have food in your stomach, it's going to slow down that alcohol getting absorbed, so it doesn't hit you as hard, apparently. So, yes, I will leave that there for a second. And the next step from the stomach is the small intestines. Now, they're called the small intestines, not because they aren't very long, but because they're small in diameter. So you've got your large intestine, which we'll get to next time. It's actually not as long as the small intestine, but it has a bigger diameter. Your small intestine is actually about 18 feet long. Just all wrapped up and crammed in there. That's crazy. So chemical digestion is completed here. So let's just rewind for a minute. Mechanical digestion and a tiny bit of chemical digestion happens in the mouth with salivary amylase. Then you swallow, the food goes down your esophagus into your stomach, and we have more mechanical digestion that happens there, a small amount of chemical digestion with that pepsin that starts to break down proteins. But this is where all the real action is going to happen, is the small intestines. So there are enzymes added from the pancreas into the small intestine. And the pancreas is considered an accessory organ, which means it has a part of digestion, but food never actually passes through it. And the three main things that you'll find in the small intestine are amylase. And remember, anything that ends in ASE is an enzyme. And like we talked about in the mouth, this digests carbohydrates. So it's going to even further start breaking those bonds in the polysaccharides that started breaking down in your mouth. There's another one called trypsin that digests proteins. So this already started a little bit in the stomach with the pepsin, but we're going to break it down even further in the small intestine with trypsin. And you've got sodium bicarbonate. I was actually talking with someone about this the other day. This is going to neutralize the hydrochloric acid that is being passed into the small intestine from the stomach, because you don't want your small intestines being exposed to that highly acidic gastric juice. So it neutralizes hydrochloric acid, HCl, and gives intestines a slightly basic pH. All right. So here we're looking at carbohydrate digestion in the small intestine, protein digestion, fat digestion. And do we cover this later? Let's see. In your small intestine, you have the lumen, which is just the opening, the tube that the food passes through. And then you have the intestinal lining, and you have all these little finger-like projections. So you've got increased surface area here because of those folds, and then on those folds you have more folds that look like this. These are called villi, and that's where the food actually gets absorbed into the bloodstream. So with carbohydrates, you're going to start with a carbohydrate. The pancreatic amylase is going to start to break some bonds so it gets into smaller pieces. And then remember, we have to break that down into monomers so it can be absorbed into the blood. An example is glucose. And then remember where that glucose is going to go is into your blood, to your cells, so your cells can take it in, do cellular respiration so you can make ATP. With proteins, so we've got these long chains of amino acids. They are broken down in the small intestine by trypsin into smaller peptides. And then another enzyme that I don't think you need to know called peptidase, and that breaks it into its individual amino acids, into its monomers. So again, those can go into the blood and be sent to where they need to go in the body. And then fats. We haven't really talked a lot about fat digestion, but globules of fat that you eat will be emulsified or broken into smaller pieces by bile from your, I believe it's from your gallbladder. And then you have an enzyme called lipase that breaks those down into monoglycerides and free fatty acids, so those can go into the blood. So just keep in mind the foods that you eat are usually long chain polymers, and to get into the blood we have to break that down into their monomers, and that's what all these enzymes are doing. So absorption, we're still in the small intestine here. The mucosa and submucosa layers form those villi that we looked at up here. And those are those finger-like projections. And what they do is increase surface area, which allows for more efficient absorption. Your small intestine has a surface area the size of a tennis court. Fun fact. And in the villi, I'm going to add some more here, sugars and amino acids are absorbed by capillaries. And the fats into the lymphatic system. I feel like I'm being super sloppy today. I hope you guys can read that. And enzymes contained within lumen and within the membrane of the epithelium. It's columnar epithelium, if you remember when we talked about that. is what contains the microvilli. And it's called the brush border. And the brush border contains enzymes secreted by the small intestine to finish off any remaining digestion before absorption. And some of these are peptidase. We know it's an enzyme because it ends in ase. Since it starts with peptide, it probably breaks down peptides. Sucrase, which you guessed it, breaks down sucrose. Maltase breaks down maltose. And lactase, which breaks down lactose. So again, I believe these are all disaccharides, and it's going to break them into monosaccharides so they can be absorbed. So as a study tip, I would track the digestion of a carb or a protein from the mouth to the small intestine. So, and I'm just going to talk through this real quick. I'm not going to write it out, but I would suggest like writing it out from the mouth down to small intestine. So with a carbohydrate, the chemical digestion of it starts in the mouth with salivary amylase. The pancreas also secretes amylase into the small intestine to break it down even more. And then you get to those brush border enzymes right here at the villi that break it down and finish digesting them into monomers for absorption into the blood. With proteins, this starts in the stomach with pepsin, and then the pancreas secretes trypsin into the small intestine to break it down even more. And then again, those brush border enzymes are going to finish breaking them down into the amino acid monomers so they can be absorbed into the blood. So again, I would suggest just getting a piece of paper, writing carbohydrate, protein, and just writing out what happens to them as they go from the mouth to the small intestine before getting absorbed into the blood, and which enzymes are involved and where. And now we gotta talk about disorders. So the three we're going to talk about are lactose intolerance, celiac disease, and diverticulosis. So lactose intolerance is the absence of the enzyme lactase, which remember breaks down lactose on the brush border, on the microvilli. And so what happens is that lactose will sit undigested in the GI tract. GI stands for gastrointestinal. And I don't have this, but I know people who do. Causes gas, bloating, and diarrhea. So diarrhea, this is a word I can never spell. here we go. Diarrhea, because lactose in the lumen, just sitting there because we can't digest it, causes fluid retention, because remember, water loves solutes. That says solutes. And so if you've got all of these solutes, all this lactase here inside the small intestine, the water is going to be drawn into it. And that's going to make you have some watery poop. Diarrhea. You get gas, bloating, and cramps. Because bacteria will slowly break down that lactose, and this releases gases. So something called Lactaid is something you can take before you eat to provide lactase to help you break down, lactase, to help you break down the lactose that your body can't naturally break down. So why does lactose intolerance cause diarrhea? Answer that right up here. Celiac disease is an autoimmune response against gluten. So the gluten bound to your intestinal wall is attacked by the immune system. Can you guys tell I'm on a time crunch? I'm writing like 10,000 miles per hour. So when your immune system goes to attack this gluten, it also damages the microvilli. And the villi. And this causes pain and malnutrition. So again, that's going to be painful. And then if you look at a normal, I don't know if these are the microvilli or the villi. This is with celiac disease. So are those going to be as effective at, there's not as much surface area to absorb the nutrients, and that's also going to be painful. Diverticulosis. Oh, a little more on gluten, if you don't know what it is. It's two proteins that give texture to food. So this is an allergy, and it's not the same as gluten intolerance. So the damage that happens here is reversible, but it can take years for your body to repair that. Okay, diverticulosis. This is when portions of the mucosa layer dive deep into underlying intestinal layers. So you get these pockets like this where bacteria can get in. And so when that happens, these can become infected and inflamed. And when that happens, it's called diverticulitis. Anything that ends in itis means inflammation of. So that would be like an infection and inflammation of those diverticula. All right, so that's where we stop for today. Next time, I believe we're going to talk about poop and the large intestine. And we'll see you then.